3, that's it. Where's everybody else? All right. Well, let's submit. See, every time I click submit, then somebody shows up. All right, at least we got Jackie in now. Still missing 3 of you. All right. Well, for those of you here, good afternoon and welcome. Today we dive deeper into chapter 2 with now we're throwing in full-on polygons and circles. And so this section brings up some new elements to play with, but at the same time, it really doesn't fundamentally change things a whole lot. So I'm going to do 2 things this morning. One, I want to go over the answers for last week's second problem set from Wednesday that we never went over because we spent Friday learning the chess pieces. And then 2, I want to talk a little bit about problem solving in general, because I don't have a good example to go through for this week because it's not all that new. There's vocabulary that we should already have and have already been working with this year. So in a way, this week might be a little bit easier than some. And we also have the reading quizzes to get through as well. Okay, Anthony has made it. Excellent. So then let's start with answers for last week's problem set. Okay, go ahead and get that out. Check your work here. And now that we're in chapter 2, now that we're past the problem-solving chapter, we get more content as we go. We're going to see that not all of these problem sets are fully problems. Some of them are just exercises. Like 23 and 25 here should have felt more like exercises to you. You should already know how to do it, and this is you're just practicing to improve and get better and faster at that operation. Okay? You shouldn't be questioning, wait, convert units? I have no idea how to do that. Where do I even begin? You already know how to convert units. You've been doing that a lot. This specific one may be new to you, right? Degrees and minutes to decimals of degrees. Maybe you've never used the minute-second system. Is it super critical, that fact in and of itself? Not necessarily. Okay, it's a nice reference here to know these 2 different systems, be able to recognize them in the future, work with either one where convenient, but again, more importantly, be able to convert from one to the other. That's the real skill you're practicing here. And so that's why it's included. So there's the answers there, converting from degree minute seconds into decimal degrees, and then converting decimal degrees into degree minute seconds, or these are actually all minutes, no seconds required. Here's another one from last week, the Azimuth. Azimuth of a line segment, right? Used in navigation. And is this, strictly speaking, useful, as it were? I think so. It's a great little navigational tool that you can use. If you're lost in the woods and you got your compass with you, you can, navigate your way with that. Is it a vocabulary term that I'm going to require you to know and bring up on the test again? No, not just. But the skill that you are practicing here when solving this problem is the problem-solving skill itself. It is more important to me that instead of just knowing azimuth, that you have the ability to be given a new thing. Here, take this, figure out how it works. Okay? That's what we're practicing with these problems, because that's going to happen to you all the time. You're going to encounter new stuff in everyday life and in your career where people will just expect you to figure it out. Okay? That's why problem solving is so important and why it's the focus of this entire semester, is you got to be able to figure things out. And this is a good figuring, okay? So with the azimuth, a direction as an angle from north all the way around, going clockwise here. So we have A lands here, B lands over here, C just there, and D all the way around to there is our angle. Okay. And then similarly, we have bearing. I did bring this one up in one of our examples. The bearing is very similar. It's a navigational tool. This one tends to be used more with like ships and planes and such. And instead of a one angle all the way around, this is between north and south here. So notice we have much smaller degree measures, and it always includes 2 indicators there. North, 17 degrees west. That means from north, go 17 degrees towards west, and that's your final actual direction that you're traveling in. Okay? It's just handy to have reference. So sometime you're reading something, reading a story, reading a book, reading an article, okay, in the news or something, I don't know, you'll come across bearing, and you'll have way in the back of your mind, oh yeah, wait, I've seen that before. We brought it up in math class. I don't remember exactly how it works, but at least it'll sound familiar to you. And then more importantly, the practice of solving a problem with this new thing. All right, so again, here is the answers. A looks about like that, B looks like this, C points in that direction, and D like that. Okay? And there, it's a sketch, all right? It doesn't need to be, you don't need to get out the protractor and measure exactly, but you could be more precise with it. Okay, any questions on the level 1 problems from last Wednesday?
No.
No? All right. Move on. Level 2 continues on with the bearing and azimuth. So here now we have the bearings of some planes that they give you the graph, and you've got to figure out thereabouts what angle those make. And you can get out your protractor and measure them. Right? And do they actually include, I feel like maybe I cut off, get the bearing. Yeah. So the neat thing here, and this is where bearing really comes in handy, is notice the comparison from tower to plane versus plane to tower, right? North 60 degrees west is saying from north turn 60 degrees towards west, and that's this direction. But the second one is saying from the plane now goes the other way back towards the tower is south 60 degrees east. And this is why the planes and ships like bearing instead of azimuth, is because to travel back and forth, you keep the same degree number, but you switch the cardinal direction. Instead of northwest, you have southeast. Right? And they all switch there. Okay, so there's that one, and then here is the second azimuth question. This one dealing with what if you were looking at the location of the sun from a city. So imagine you could actually see the horizon all the way around you. There were no buildings, no trees, no hills getting in the way. You could turn 360 degrees around and see the horizon, the perfect circle around you. Right? That's what this represents. You are here in the city. You look in the circle around in any direction and find where does the sunrise occur. Okay, so this is a top-down view of your standing here in the middle of the city. And so from the given measurements, here we have, right, in Oslo, the azimuth of sunrise is 36, sunset at 323. So we go here in this circle and put the rise there, and then 323 all the way around to put the sunset right here. And we're just looking for, relatively speaking, notice where they are positioned on the globe is going to affect where we see this rise and set. Right? Notice these are much farther apart, way down lower. It's because it's much further south. They got longer, more daylight hours, right? There's the last one down there. And then level 3, I preempted this in the directions to say, hey, check this one out, because you're going to make a really cool picture. Look at this. The Bezier curves refers to this curve inside of here that is created out of straight lines. So if someone asks you, hey, riddle me this, how can you create a curve using only straight lines? Bezier is your answer, okay? This is what video games do with their 3D graphics all the time. This is how all curved surfaces in computer graphics are actually being modeled, some version thereof, but it's based on this concept. You can approximate with many, many, many straight lines in sequence like this. And you connect them. You don't connect 1 to 1, 2 to 2, 3 to 3. You're not making stripes across here. You connect instead 3 to 1, 2 to 2, 1 to 3. Right? So the last one connects to the first one, and then the second to last to the second, third to last, third. Right? And across here, it creates this really cool picture. There's the one at 90 degrees. Look at that. That's just lovely. Little curve there. I love these things. These are awesome. And if you like them too, fill your sketch. Draw them everywhere. Here I decided to get fancy with it, and I picked rotated colors through each line into a gradient here, and then you got this lovely little arc of a rainbow. Look at that effect there. Isn't that nice? Okay, beautiful. I'm no artist, right? I'm just taking advantage of geometry here, okay? And systematic approach, and I can make something look pretty nice, right? That to me is cool. Okay, any questions on the level 2 or 3 problems? Sometimes geometry is just pretty, okay? We do it because it's pretty. All right, now, as I mentioned, I don't have an example for section 2.2 for you. I do have the problem set here. We're getting into polygons and circles, right? Types of polygons, naming hexagon, square, right? Naming the types of quadrilaterals, square, and parallelogram, and trapezoid, right, is always the weird one. Types of triangles, isosceles and scalene and all that. All that vocabulary. This is predominantly a vocabulary-heavy section. And so I didn't have a good, here's a good problem that exemplifies knowing the different vocabulary. I either already put them into the problem set, and I'd be giving it away, or it would be so specific it wouldn't really carry over, except in the general problem-solving approach. And so instead I want to talk about an example of real-life problem solving. So imagine this. Imagine you have a gold bracelet that fell, got crushed, stepped on. I don't know. It's an old family heirloom, and it's been mangled over the years, and it's kind of bent and crooked. It's supposed to be a perfect circle, but it looks all like this. That's like a figure 8. Right? It's all been messed up. How are you going to fix that? How are you going to bend it back into a perfect ring? Imagine that scenario. Answer it seriously in your mind. How would you actually do that? What skills do you have? What tools do you have at your disposal? Okay, is going to make a huge difference to how you answer that question. Okay, if you can't for the life of you find a pair of pliers around the house, it's like, oh, you're going to have to hold it by hand and try to. Maybe you have a hammer. You ever heard the phrase, if all you have is a hammer, every problem looks like a nail, right? All you can do is pound on it. You can beat it back into shape, right? That's generally what smiths do, is take it to the anvil and just pound it until it gets to a circle. But what about the fine finish, the intricate little carving texture around the outside? You're going to damage it, right? How are you going to fix this thing properly? You need a good tool set. And so to me, this section, section 2.2, let's look at the text again. Right, we've got these concepts such as symmetry, the list of types of quadrilaterals, the names of the polygons, the features in the circle, the names of the types of triangles. All of these build up your toolbox, your knowledge base that allows you to solve a problem faster and easier. It's not the problem-solving skill. That's another component. That's what we practiced in chapter 1. But now we're filling out your toolbox so that you can recognize concepts and be like, oh, that's one of these things. Well, I can just apply this strategy. Works on those things. I know that. This concept, oh, I recognize this triangle. It's an equilateral. I know all kinds of things about the equilateral triangle. Now it's easy, right? If you don't recognize the equilateral triangle in the first place, suddenly the problem becomes much harder. Let's go back to that bracelet. Check out this guy. He's got a gold bracelet that's bent out of shape and all mangled and mashed up. But look at the tool he's got. Look at that. And done. Perfect circle. He makes it seem so easy. That's because he's got the specialized tool, right? He's got that in his toolbox, so now this isn't a problem for him at all. He's like, oh, I've got the tool to fix that. I can take care of that, no problem. It's an exercise, really. He could do this all day long, repeat one after the other, doom, 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 just churn them out, right? Start a bracelet fixing business with that thing. This is literally from Reddit, our specialized tools, okay, for this exact reason. The more tools, the more specific your knowledge base, the more specific your familiarity with the objects in the problem, the easier it's going to be. So this week, you're going to recognize a lot of things. They might seem like exercises to you, okay? But you're building up that experience so that things become easier over time. All right? There you go. I love that when you get to see it again. Any questions on that concept? No? All right, then, that's your problem set for today. Before I turn you loose on that, we have one more thing to do, and that is the quiz is. So let me restart that. I think if I hit this button, there we go. Boom, ready to go. Joinmyquiz.com. Enter the game code 184572. 184572. Go ahead and join. Take the reading quiz, get your score on the board. Retake code will be posted at the end of the class day. You can repeat as necessary all through the week. But I want to see how much you recognize and remember as of now. Here they come. 3 out of 5. 5, wait a minute. We've lost some people here. What happened? Had all 7 for a while. All right, I'm going to assume internet problems here. Give you another minute to join in. Okay, this one has, I believe, 15 questions. Again, centering on all that vocabulary, symmetry, the quadrilaterals, the types of triangles, the parts of a circle, definition of polygon. All that is thrown in there. Let's see how much you either remember or if you had it in your notes, you can use your notes on the quizzes. If you're in, go ahead and get started. code is still up and active. When you are done, go ahead and start on tonight's problem set.